Welcome back. As promised, I am going to work you all two sets of compounds. All right. I'm not going to tell you whether they are enantiomers, diastereomers, or identical to start. That's our job to figure out as we work this problem out. Now, if you notice on the first set, A and B, I didn't give any Cl, OH, Fi, etc. because I think I want you to get used to the idea of just seeing carbons and hydrogens, because that's essentially what we start at our first class up until class 8 or 9 is when you start to see chloros and hydroxys and stuff, right? So let's assign priorities. As I said, first your job is to assign priorities, and if you notice, this carbon is attached to a carbon which is only attached to 3 hydrogens. This carbon is attached to a carbon which is in turn attached to only 1 carbon and 5 hydrogens. This is attached to 3 other carbons. This is attached to 4 other carbons. Clearly, the one with the 4 carbons gets the first priority, 1. This will be 2 because it's 3. This is 3. And that'll be 4, right? Okay, so what does that mean? Now we have to first go and connect the 1, 2, 3s, right? And that is a that's a clockwise, right? And our lowest rank group is in the back position, right? So what does clockwise back means in our little table? I'm not going to bring the table because of space. Clockwise back is R, okay? So this right here, folks, is R. Okay? Let's do that same for this one. So again, this will be the first priority. Actually, I'm going to switch colors. So red for blue, blue for red. So this will be 1 and 2, 3, and 4. The lowest rank doesn't always have to be hydrogen, okay? Whatever is the lowest rank of the 4 must be in the front or back positions, right? So that means this is the only way we can connect it. That is still clockwise, right? Still clockwise. It's not counterclockwise. It's still clockwise. And the lowest rank group is in the front. And if I am not mistaken, if clockwise back is R, clockwise front should be S. I don't think I need to even look it up. So this was an R. The A was R. And B was S. And if A is the original and B is the mirror image, okay, these are opposite. So these two are enantiomers. Okay, now let's go get maybe a black to work out the remainder. Okay, let's go to this one. Again, this is a chiral carbon. It's attached to a hydrogen, bromine, this long lengthy group, and a methyl group. Clearly, what is directly attached to what we focus on? So this is attached to a carbon, this is attached to a bromine, hydrogen, and another carbon, right? So this gets number 1 priority. This is attached to a carbon. This is also attached to a carbon, but keep in mind, this is a methyl, so it only has 3 hydrogens, whereas this is much more bulkier. So that means that'll be 2, and this is 3, and that'll be 4, right? So 1, 2, 3, 4. 1, 2, 3, this is clockwise, and the lowest rank group is in the front, and we know clockwise front is yes. So this is yes, right? Let's solve this one. So this is 1. This whole thing is, oh, actually, let me get a different color so it doesn't convolute your understanding here because of the colors. So this is 1 because this is directly attached to the Cl, even though Br is big, but it's attached to a carbon. With this carbon is attached to this carbon, which in turn is attached to Br. It's not directly attached to the Br. However, that still gets number 2. This gets number 3, and this gets number 4, right? Okay. Right? Did we get that right? Very good. So now if you notice, our lowest rank group is not in the plane, right? So what can we do to make that achieve? So what we can typically do is, just like we did in the previous case, we can swap with the carbon with the number one priority group. So what we can do is take the hydrogen and replace this with hydrogen and replace this with Cl. Okay, now that'll change that'll change everything, right? So this will now become 1, this will be 2, 3, and that'll be 4, right? So 1, 2, 3, that's still clockwise, and it's in the front position, so this is S, right? Right? Very good. Okay, so that's S, and then what about here? So let's go to this one. So let's get a different color. Now again, if you have trouble with this particular concept, you're welcome to ask questions during class. So this is 1, this is, this gets 2, this gets 3, this gets 4. It's no problem. It's counterclockwise, right? Counterclockwise, and it's hydrogen is in the front, and counterclockwise front is R. Well, that's what we want to see because I know what this compound is. Okay, and then we go here. Let's get a different color again, maybe a red. Okay, again, this is attached directly, so 1, this whole thing is 2, this is 3, and that's 4, right? Now normally we will take away the 1, assign 1 to the hydrogen, and take away this, assign it number. So let's do this. So we're going to get rid of this, put our hydrogen here, take out the hydrogen, put it the Cl here. Normally we swap with the number one group, so that means that it changes everything. This becomes 1, this becomes 4, right? That means 1, 2, 3, right? That's counterclockwise, and it's in the back, right? Sorry, this is clockwise. This is clockwise and back, which is what? Clockwise and back is R. That's exactly what I wanted to see because I know what the answer is. It's SS, right? This is RR. So what is that? It's complete opposite. So this would be an enantiomer. I highly recommend you don't just watch this video one time and think you will get it right. Normally, at least the first set was quite straightforward. There was no problem. Even in the second set, it was only that second part of that compound where the table doesn't help you much. You have to do, just like I've told you in the previous videos, that you normally would take out where that number one group is, put the fourth group there, and then swap the position. It's just that simple, okay? I'm making it so simple for you, okay? If you look at it online, there's probably, like I said, a million different ways people would teach you this, and then there's probably 1% of it would actually be helpful on most cases. Some problems would work one problem, and the second problem, it'll fail. And if you fail 4 or 5 problems in a row, then you get flustered and you get confused or overwhelmed and think, how am I going to ever get through this? Well, just don't watch anything else until you finish my videos. Once you finish my videos, ask me questions, and then you can venture on your own, look for some practice problems. But the level of practice I give you in class, I don't think you even need to venture into outside sources. I'm not discouraging you from using outside sources, but if you watch too many sources, even outside completely, let's say you watch 4 or 5 sources, each of them would approach it completely different, and even you have no benchmark on which one to follow. That's why I'm saying these concepts are very complex, and I highly recommend you stay with one or the other. All right? in the next set of videos, what we are going to watch is we've saw the full skeletal structures with carbon and hydrogens. Then we went to condensed line structures. And then now we're going to watch something called a Fisher projection and a Newman projection. Okay. If those names sound unfamiliar to you, well, you're not alone. I don't think any of you that have never taken organic chemistry class before probably have never encountered many of these names. So I will teach them as two separate videos just to avoid it being complex and easy on you. So this is all I have to say about enantiomers, diastereomers, and identical. Obviously, I could have worked more problems for diastereomers, but let's see how this goes. And then, I mean, if you know one, you can do rest. It's all about assigning R and S, okay? And then you use that little synopsis chart I showed you and the difference between enantiomers, diastereomers, and identical. That's all you need, okay? Let's not make this much more complex than it already is. So I'm gonna stop the discussion on this here, and if needed, we can come back and maybe create another video later. But I want you to first understand this and practice problems I give you first, and then we can decide if you need more or less, okay? And then the next video, I'm gonna talk about Fisher projection, and then the video after that, I'm gonna talk about Newman projections. And then just like how we did stability for alkenes based on the Zaitsev rule, like which one's more stable, which one's less stable, we're gonna use the Newman projections and relate it to the alkanes, the very first thing we learned, and then compare its stability, okay? So stay tuned for more videos. I'm gonna come back with a video on Fisher projection and Newman projection, and then hopefully that'll put us on top of our stereochemistry learning. All right, so stay tuned for more videos.